So our project problem is finding the volume of the solid obtained by revolving the closed region bounded by the line y equals x and the curve y equals x squared about the line y equals x, which is this one. What makes this problem particularly tricky is the fact that you can't find the volume of it by integrating with respect to x or y like we traditionally do, because if we do that, it's going to give us ellipses and not circles, and they're all going to be of different areas. So in order for us to get uniform circles, in order for us to take the integram of, we are going to need to make a new axis, which is called the t-axis, which is just y equals x. And we're going to have to change all of our variables in terms of that new t-axis. And with doing that, we're going to get cross-sectional slabs that look like this, with a radius of r and a thickness of delta t, and that will allow us to find the volume of it.
So now we have to find the points of intersection, and we do that by setting the equations x and x equal x squared equal to each other. So you just do that, and then we bring x squared to the other side, and we factor. And when we do that, we should get x equals 0, and then x equals 1. Now that we have our x values, we can plug this back into our y equation, and when we do that, we'll get y equals 0 and y equals 1. So then the points here become, this becomes 1, 1, and this becomes this point right here becomes 0, 0. Okay, so now we know that this side is equal to 1, it has a length of 1, and we know this side has a length of 1, but we want to find the length of this side right here along the t-axis, and to do that we'll have to use Pythagorean's theorem, which is a squared plus b squared equals c squared. And for a and b, we just plug 1 for a and b, so then we'll get 1 squared plus 1 squared equals c squared, and that would mean c squared is equal to 2, and to find what c is equal to, we just have to square root both sides, and you get c is equal to the square root of 2. So then this side has a length of square root of 2.
We can find the length of the hypotenuse of this triangle using the distance formula. So this triangle is kind of a mini image of this one right here. We still have our t over here, we have our 0 and 0 over here, and we have our radius x comma x squared over here. So now we'll find the distance formula to find the hypotenuse. So I'll do that right over here. Now remember that distance formula is equal to d is equal to the square root of x squared, or sorry about that, x sub 2 minus x sub 1 squared plus y2 minus y1 squared. Now if we look at what we have, we can say our d is equal to, our x sub 2 will be x, and our x sub 1 will be 0 squared, because our x2 is here, which is x, and our x1 is 0. And then that's all squared, plus our y sub 2, which will be x squared, minus our y1, which will be 0 squared. And once we do that all out, we will get x squared plus x squared, x to the fourth.
Okay, so now that we have found our length of our hypotenuse of this, we're going to be able to form a relation between our t variable, our r variable, and our x's by using the Pythagorean theorem, because we have our hypotenuse length, our t, and our r. So we're going to do hypotenuse, which is x squared plus x to the fourth, square root of that, squared, plus is equal to a squared plus b squared, so t squared plus r squared. And since we're squaring a square root, that just drops the square root, so we're left with x squared plus x to the fourth is equal to t squared plus r squared. And we know that we're going to need r squared as r squared instead of just r by itself, because in our volume formula, since we're going to be taking the area of circles to find volume by integration, it's going to be in the form of pi r squared. And then dt, once we take the integral with our respective bounds. So in order for us to isolate r squared, we're going to subtract it from both sides, which leaves us with x squared plus x to the fourth minus t squared is equal to r squared. So that's going to be our first relationship formula between x, t, and r. Okay, so for us to find our second formula that relates t, r, and our x values, we're going to have to take the distance formula once again. But this time, if you look at our blown up cross-sectional slab or slice, there is another triangle that we can inscribe in here, and that's going to be this triangle. So this is the first one we use, this is going to be the second one, and we're going to also use the distance formula to find out the hypotenuse of it. And we know that the full length of this side is the square root of 2 after using the Pythagorean theorem, and we know that this length is t. So the length of this side is just going to be the whole one minus this side, so it's going to be square root of 2 minus t. So our distance formula is x2 minus x1 plus y2 minus y1. In this case, our x2 is going to be 1 from here. Our x1 is going to be x, that quantity is squared, plus y2, 1 as well, minus x squared, this squared, and all this is going to be square rooted. So now we're going to have to factor out these. So if I do it, so that's what's going to happen when you factor them out, and then if we simplify them, so this is going to be our distance, and then we can actually add these because now that the squares are gone, it's just a regular equation. So when you add that, you're going to have x to the fourth. We've got a 2x squared here, a negative 2x squared, and a positive 2x squared, so you're going to be left with 1 negative x squared. You've only got one term that has it 1x, 1 plus positive 1 plus 2, and then this quantity is squared. So this is equal to this hypotenuse. So now that we have our value, or our length for our hypotenuse, we can use the Pythagorean theorem once again in order to relate all three of our variables. So we're going to do r squared plus this quantity, square root of 2 minus t squared, is equal to our hypotenuse length squared. So once again, when you square a square root, that can just drop the square root, so you're left on this side with x to the fourth minus x squared minus 2x plus 2. And on this side, I'm going to do the factoring down here. Square root of 2 times square root of 2 is just 2 minus the square root of 2t minus the square root of 2t plus t squared. When you combine these two, you're going to get 2 minus 2 square root of 2t plus t squared. So now we're going to input this in for here, for this value. So while this equation looks like a whole mess, what we do have is a equation that we just solved for that is r squared, which is up here. It's equal to x squared plus x to the fourth minus t squared. So if we plug that in, you're going to notice a lot of things are going to cancel, which makes it a lot easier to look at. So instead of r squared, I'm going to put in x squared plus x to the fourth minus t squared plus 2 minus 2 root 2 t plus t squared, x to the fourth minus x squared minus 2x plus 2. This negative t squared and this t squared cancel. If you subtract 2 from both sides, these 2's will cancel. If you subtract an x to the fourth from both sides, these will cancel as well. And if you subtract an x squared from both sides, it'll just leave you with a negative 2x squared minus a 2x is equal to a negative 2 root 2t. So now what we're going to do is divide by a negative 2 in order to try to isolate this t. And that cancels all of those 2, so you're left with root 2 t is equal to x squared plus x. Where here, what we can do is multiply both sides by 1 over root 2 in order to cancel out this root 2 from this side. So it's going to be x squared plus x all over root 2. However, we can't leave it in this form, so what we're going to do is multiply it by root 2 over root 2. That'll give us 2 over root 2 x squared plus x. And that is our value for t that relates to x. So now that we've got two separate equations that have x variables, one has just t and x, the other one has r, x, and t, we can actually plug this equation in for our t in this in order to try to get rid of one of the variables, so that'll eliminate t out of here. So we're going to do r squared is equal to x squared plus x to the fourth minus this quantity, x squared plus x root 2 over 2. This whole thing is squared. So now it's going to take a little bit of algebra in order to factor this thing out. And we can just break apart, if we distribute the root 2 to each one of these and distribute the division of 2, we'll end up with this. And this is going to be squared. So it's just going to be multiplied by itself. So the first term is going to end up giving us x to the fourth, square root of 2 times square root of 2 is just a regular 2, and then over 4, but it's 2 over 4, so it's just going to be x to the fourth over 2. And then the same thing is going to happen with the x squared and the x, however it's going to give you x cubed over 2, plus another x cubed over 2, plus an x squared over 2. These two halves will join to make one whole x cubed, so it's going to be x to the fourth over 2 plus x cubed plus x squared over 2, and then that's going to go in for here, so that's all gonna be a negative, and you're gonna have an x to the fourth out here, a positive x squared out here as well, and that's all gonna equal your r squared. So now if you distribute that negative, you're gonna notice that you have a full x to the fourth and a half of it, so you're gonna be left with a positive x to the fourth over 2. You have a negative x squared over 2 and a positive full x squared, so you're gonna be left with a positive x squared over 2. And you have a negative x cubed. And that is gonna equal r squared. So now you have a formula that relates r and x without the t.
So now that we have t, we need to find dt, so we can start to put together this whole volume formula. And t is, so now we need to find derivative, which is dt. So if we start dt will be, we'd start taking it down by, let me just move it down. So dt will be 2x root 2 over 2 plus, and the derivative of this x will just be 1. So it will just be root 2 over 2. So now we can begin to simplify our dt. The 2's will just cancel out. So it'll be x root 2 plus root 2 over 2. And that is all in terms of dx. Because we need to get back into dx so we can change our bounds back to the x values.
Okay, so now that we have our equation for r squared, we can plug it into our volume formula right here. And then when we do that, we get this. We can take the pi out because it's a constant, and we're left with this. We also plug in what we got for our dt. And this is what we're left with. Now because we're integrating in terms of x, we can use the bounds for x, which are 0 and 1. We just have to do that. Now to further simplify this, we just have to FOIL these two. So now we just have to FOIL this, and then once we do that, we get the integral of 0 to 1 times pi, and then inside we'll get x to the 5th square root of 2 over 2 plus x to the 4th square root of 2 over 4 minus x to the 4th square root of 2 minus x cubed square root of 2 over 2 plus x cubed square root of 2 over 2 plus x squared square root of 2 over 4 dx. And then we can simplify this even further by by canceling out like terms. So these two will go away, and then we're just left with this. x to the 5th square root of 2 over 2 minus 3x to the 4th times square root of 2 over 4 plus x squared root of 2 over 4 dx. Now we just have to integrate this. So now after simplification, we're left with this equation right here. Pi times the integral from 0 to 1 of x to the 5th times square root of 2 over 2 minus 3 x to the 4th times square root of 2 over 4 plus x squared times square root of 2 over 4. So now we can finally integrate to find the volume, and this is so. If we add the exponent and bring it down, we should get this for the first term, x to the 6th square root of 2 over 12, and we do the same thing for the next term. It'd be 3x to the 5th square root of 2 over 20 plus x cubed over square root of 2 over 12, and we times this all by pi. And now we can finally integrate it from the bounds at 0 and 1. And then when we plug in 1 for x, we should get 1 to the 6th square root of 2 over 12 minus 3 times 1 to the 5th square root of 2 over 20, and then plus 1 cubed square root of 2 over 12. And then we also have to plug in the bound, we also have to plug in 0, and if you just plug in 0, that'll just be 0. So we just subtract 0, and after we further simplify this, we should get the volume should equal pi square root of 2 over 60. And that is the volume.
And bing bing bada bling bling bling, you get your answer. So in conclusion, after finding our total volume for the solid, what we learned from this project problem is that you can find a lot of relationships between variables by using geometry and right triangles, Pythagorean theorem, distance formula. Those two really help in relating all of our variables together. It also required extensive algebra, like this whole board was filled with x's and t's and r's. So making sure that your work is clean, neat, and organized really helps to eliminate room for error. And it also required integration techniques. Once again, just basically the power rule for integration, and all of that was utilized in order to find our final volume.